All right, so let's wrap up fossil fuels today. We've already talked about coal. Remember, that's the solid form of fossil fuels. We are one of the countries in the world that has the most of this, maybe anywhere from 100 to 150 years of supply. But we haven't talked yet about oil, which is the liquid form, and natural gas, which is the gaseous form of these materials, these fossil fuels. So let's do that. We're going to talk about oil first, and then natural gas. First, we're going to talk about, how we get them out of the ground, which is important, how we process them, and then what some of the environmental consequences of each are. All right, so liquid petroleum is, you just take this out of the ground. It's a liquid, right? We have these kind of wells all over Texas. Remember, it's made from decaying organic matter. And it's extracted by drilling a well deep into the earth, into a deposit, where there's this liquid, and then you just basically pull it out with a straw. That's one way to get liquid oil. Another way that we can do this is sometimes liquid oil isn't just a pot of liquid in there that we can get out with a straw. It's basically a sludge that's kind of embedded in the sand formation of the geological formation. And so what we do then is we have this bitumen, which is a thick, sticky, semi-solid form of petroleum. It's not a liquid. And we're basically going to have to put water and steam in there to get that oil separated from the sand. Either way, both eventually become liquid form once it's removed. Tar sands is kind of what you would call a more unconventional form of oil. This is a great picture of what it looks like. So again, instead of finding the liquid in a formation down below and pumping it up with a straw, we're going to have to get this stuff and use hot water to get the oil out. Most of these formations are in Alberta, Canada, and we talked about the Keystone Pipeline and getting these tar sands down from Canada all the way down to refining in Houston. It can be pretty environmentally damaging, but there's lots and lots of it. And so it is a more expensive version of crude oil, but in times of scarcity, it's an alternative. Now, both tar sands and crude oil have to be refined. What does that mean? Well, this picture right here kind of shows you what does a liquid cup of crude oil look like. It's got all these long chain hydrocarbons. Carbon, this one has one carbon, that's methane. This one has 1, 2, 3, 4, 5 carbons, that's pentane, and on and on. So this crude oil that they get out of the ground is this mixture of all of this, what are called hydrocarbons, in one basic slurry. What we need to do is we want to separate the little ones from the medium ones from the big ones, because each one of these long chain hydrocarbons has a different function. What we do is we take it, and this is a one way to look at the column, we're going to put it in a furnace and we're going to heat it up. The really long chain hydrocarbons are going to be really hard to boil and get off the top. They're going to stay at the bottom, whereas the smaller ones will go out the top. And so what we end up doing is the small things like methane. Here's propane that you use in your barbecue grill. Jet fuel has 12 and 15 carbons. Vaseline is going to be even higher with 86 carbons. I can pull these, I heat them up, and then I can pull them off in segments of the column based on temperature. And these can be packed up, barreled up, and shipped off. This is what's called refining of the crude oil, which means taking these materials out of the mixture and separating them each for use. What about the gaseous form? Let's look at how we do that. Now, the way that we traditionally now are getting methane gas out of the ground is through fracking. Fracking is a process where the gas, it could be found in pockets where it's just a gas that we can pull out of an oil formation, much like crude oil. But in other cases, it's actually in the rock. So what I want to do next is talk about how we get that shale oil out of the rock. All right, so let's look at this. This is your diagram. Remember, everyone has to participate on this. I think this is one of the last pages of it. Now, this here is a traditional oil well. We have these all over Texas, right? So what's going to happen is I've got our aquifers. So let me this. So most our usable aquifers are going to be here right below a layer of topsoil, right? So this is our groundwater. And this is important because our groundwater is deep in the earth, and so are these processes. And so are these right here, right? If these leak, that goes into our groundwater. So anytime you drill, you always have the risk of there being leaking in the water table. Okay. Then we're going to have an overlying sedimentary cover. Sedimentary cover. And then we've got an impermeable shale. Porous sandstone, followed by impermeable shale again. So in a traditional well, so here's our underlying sedimentary lake cover, right? And then we've got our impermeable shale. I'm going to use a orange just because I want to highlight this. Shale is rock. It's a sedimentary rock, but it's a solid rock. And this, again, is going to be more of a porous sandstone. These are typical geological formations. And periodically, you have these pockets of ancient sunlight, decaying plants and animals from millions of years ago. This is oil. It's a liquid. It's crude oil. And then sometimes you get natural gas here. In a traditional well, you can pull out the natural gas and or you can pull out the crude oil, both. So that would be a more traditional type. Now, interestingly, however, is that this was what we were going to call a modern well. And this is what's happening all over Texas in the Permian Basin. And that is that they have found that a lot of this shale actually has methane gas in the rock. So what they do is they pump a bunch of water and chemicals, and they blast this water and chemicals into this rock. And that fractures the rock, so the rock splits. Imagine it like a big pressure washer. The rock splits and out bubbles the methane gas. And a little over here. And a little bit over here. And that gets pulled back up to the surface and can be used pure. So fracking is this process. Traditional oil well formation or retrieval is this. Now you can see why there might be some problems with this. First of all, fracking causes fractures in the rock. And people are worried, even though this is far away, that these gas bubbles and other contaminants could end up in the water table. Also, as opposed to this one, which is just a pump, pumping the liquids out of the formation, we've got to use all of this fresh water and all of these chemicals and put them down deep into the earth in order to break these rocks open and let the gas come out. And so it's a very water-intensive process. So that is another criticism. One thing to note about this is that methane gas when you retrieve it, because it's a gas, doesn't have a lot of impurities. The crude oil here has a lot of impurities in it. This doesn't. So we're going to learn in a minute here that it tends to burn a lot cleaner. So we're going to pump down water and or chemicals to fracture the shale rock, and gas is released.